Part 2, we're going to start with example 3. And remember, I just got through teaching you substitution and I just got through teaching linear combination. Now, it depends on the equation and your personal taste on which one you like to use. Some of these are easier solved using the substitution method that I taught above, and others are simply just not worth your time. I'm going to go ahead and pull out example 3 for you, and you have 3x minus 4y equals 14, and you have 4x plus 10y equals 11. Now, there is nothing that is identical or opposite. Okay? We're going to have to do some multiplying, but I can't turn a 3 into a 4, or vice versa, and I can't turn a 4 into a 10, or vice versa. So I am going to make a determination here that I am going to multiply everything out to create a negative 40 in the center. Okay? I mean to create a 40 in the center. So this guy will get multiplied by a 10 to create a negative 40. And this guy will be multiplied by a 4 to create a positive 40. Then when I use the linear combination method, this item will cancel out. So the first equation, 30x minus 40y equals 140. That's the first equation. Multiplied by the 10 so that I would create a 40. This guy, 16x plus 40y equals, is that 44? Okay, that's this guy after multiplying. Now, got everything set up? Let's start combining here. You should end up with 46x equals 184. Divide by 46, and you determine that x is 4. Okay, I now have the first part of my solution, 4, but I need my y value. Pick your poison. Plug it in here, plug it in here. I am going to plug it in here, just because that's what I want to do. 4 times 4, which you already know is 16. 16 plus 10y equals 11. Some of these are going to look ugly, like this one, for example. I'm going to subtract 16, and I'm going to get 10y equals negative 5. I'm going to divide by 10, and I'm going to get y equals negative 5 halves, which is negative 1 half. Okay? Make sure you do reduce. There's your answer. Okay? That finishes that one. This would not have been very convenient to try and put into the substitution method because it would have been very difficult to solve for x or y. You would end up with fractional forms, and that would have just been a mess to play with. So this method, I would always, always, always recommend using the linear combination method. Okay? Now, that being said, example 4 is one where it's pretty clear which method you're going to use. Example 4. We've got x plus 2y equals 11, and that should be a 1, and y equals negative half x plus 4, negative 1 half x plus 4. Look at that, y equals. So this mess can get substituted for the value of y, which will look like this. X plus 2 times negative 1 half x plus 4, because this is y, equals 1. Okay? Y is this, so we substituted it in for y. There it is. Now, positive 2 times negative 1 half negative x. Okay? Negative x. Bring down your other x, by the way. 2 times 4, positive 8, equals 1. Let's collect like terms. X minus 8 is 0, so those disappear, leaving me with 8 equals 1. Not in my universe, folks. That is a no solution equation. On the previous page, I shared with you that if you have no solution, it is quite probable that you have parallel lines. No solution. Lines are parallel. Not that you needed to tell me that, but you have no solution. Okay? The lines are parallel. They never touch one another. Moving on to example 5. Negative 3x plus 5y equals negative 6 and 6x minus 10y equals 12. Okay? So, look at this. Let's multiply this equation here by, this equation here by a 2. That'll create a negative 6, won't it? Won't that be handy? So, 2 times that, negative 6x. 2 times positive, plus 10y. 2 times that, negative 12. If we add all that together, I get 0 plus 0 equals 12. Is that true? Well, yeah, 0 is 0. So all numbers that satisfy one equation would satisfy the other. Okay? All numbers that are good in one are good in the other. Okay? So you cannot just tell me all numbers, because that's not correct. That's implying that the entire graph is covered by these. But what you do have to tell me is a few solutions that would make this work. Okay? A few solutions that would make this work. They've given us 3 in our book. They have 0, negative 6/5. They have 2, 0, and they have 7, 3. So I'm actually going to show you how you can find some solutions. I'm going to take this mess right here. And I am going to draw a table of XY values. Remember, we've determined that these two lines are coinciding. They're one on top of the other because 0 equals 0. Identity in this case means that they share the same space. What if I say x is 0? 0 minus 10y equals 12. Divide by a negative 10 and I get what? I get a negative 6/5. That's actually one of the ones they came up with. Okay? Now I'm going to plug in y as 0 to come up with a second solution. Okay? So 6x minus 0 equals 12. X will be 2, won't it? And that's another solution that they have. For me, if the lines are coinciding lines, one on top of the other, like the first page said, in example C there, if the lines are 0 equals 0, which means they coincide, then you need to give me 2 solutions, unless the book tells you otherwise. Let's see. If a system has no solution, oh no, the book says give 3. Doggone it. All right, so let's give 3. You have to give 3 solutions. I thought the book only said 2, and I would have been quite comfortable with that. But let's verify it. Let's do what the book says. Let's do x is 1. If x is 1, then it's 6 times 1, which is 6 minus 10y equals 12. Subtract 6, negative 10y equals 6. So I have y equals negative 6/10, otherwise known as negative 3/5. fifths. Okay? Now I have 3 solutions, and haha, that's not one of the ones that they have. So there is my list of solutions that you will need to have for me. Okay? So this is not easy stuff, and I highly recommend that you review this video. This video can be found on TeacherTube, and assuming that internet connections work well tonight, it will be uploaded for your perusal between now and then. So if not, when the school gets the internet up and running, you'll have access to all of my videos. I am putting them all on TeacherTube for you to work with. That is the end of lesson 3.5, Algebra 2. Today's homework assignment is 3.5, 1 through 31. You're doing the odds today, and I expect to see work. If all I see is answers, it's not going to be worth my time, and it's not going to be worth a grade. So do your best. Good luck.